Example 6. You decide to use chalkboard paint to create a chalkboard on a door. You want the chalkboard to cover 6 square feet and to have a uniform border as shown. Find the width of the border to the nearest inch. Okay, so if you look at the picture, the chalkboard is going to be the green part. Okay, and we know that we want the chalkboard to cover 6 square feet. So I know the green part is 6 feet squared. That's the area. And around that, I wanted to have a uniform border, meaning the width up here is going to be the same as the width over here, which is the same as the width here, the width here, and the width here, which I don't know what that is, but I do know that it's X. So we need to figure out how wide this brown door part has to be in order for our chalkboard to have an area of 6 feet squared. And we know that it's going to be on a door that's 7 by 3. So the first thing I'm going to look at is I'm going to look at this. And I know that the area of this is length times width. And I know that that area has to be 6 square feet. So the question then becomes, okay, well then what is this length and what is this width? Well, the length of the door here starts at 7. Then I have X here and I have X here because that's my border. Well, so when I come to now here, which is my chalkboard, it was 7, but I'm subtracting 2x. Now, if I use that same idea, my width of my chalkboard was up here, the door was 3. But I have x here and I have x here, so this is now 3 minus 2x. So my length is 7 minus 2x, my width is 3 minus 2x, and this has to equal 6. Now we have to solve this. In order to solve this, this is a quadratic equation, and we have a couple different options. Option 1, we can solve by graphing. Option 2, we can solve by square root. Option 3, we can solve by completing the square. Now, no matter what we do, my first step is going to be to get this out of factored form and into standard form. And I'm actually just going to put this in a box because when I'm done with this example, I'm actually going to show you a different way and see what happens. So keep that in mind. If we're going to get this out of factored form, we're going to distribute. So 7 times 3 is 21. 7 times negative 2x is negative 14x. Negative 2 times 3 is negative 6x. Negative 2x times negative 2x is positive 4x squared equals 6. Then I'm going to combine like terms. So I have a negative 14x and a negative 6x. So 21 minus 20x plus 4x squared equals 6. Then usually a good idea when you're solving a quadratic equation is get it equal to 0. So I'm going to subtract 6 from both sides. 21 minus 6 is 15. And then I'm going to rearrange a little bit. So we're going to have 4x squared minus 20x plus 15 equals 0. And that 15 just went right there, 21 minus 6. And that's what we're looking at right now. Now, if we're going to solve that, I really don't want to complete the square. And the reason is because my leading coefficient is not a positive 1, and I really don't want to divide all of these numbers by 4. I could divide this by 4, but that's not going to divide by 4 nicely, so I don't want to do it. My other option would be solve by square root, which we can't do because there's a b value. So at this point in time, our last option is going to be to solve by graphing. Over here, 4x squared minus 20x plus 15. I can put this back in a standard window, and I'm looking at my x-intercepts because our equation was equal to 0. So my first one is x equals 0.919. My second one is x equals 4.081. If I come back over here and I have both of my equations, or I'm sorry, my solutions, x equals 0.919 and x equals 4.081, take a look over at your door. X is representing the width of the border. Which one of these won't work and why? And the answer to that is the 4. The width of the border at 4 can't be more than the width of the door, which was 3. So that's telling me that the width of the border has to be 0.919 feet. And in the directions, it told me that we're going to find it to the nearest inch. So if I round this, x equals 1 foot. And actually, wait a minute, it says to the nearest inch. Okay, so if there's 12 inches in a foot, get rid of that. That means we have to take 0.919, multiply it by 12, because there's 12 inches in a foot, which is going to give us 11.028 inches. And then if we round to the nearest inch, that's going to tell us 11 inches. So our uniform border has to be 11 inches the whole way around the door. Now, remember when I said I wanted to come back and I wanted to look at this original equation? So that original equation, we have 7 minus 2x, we have 3 minus 2x, and we have equals 6. Now, go grab your calculator, and we're going to see if we can get the same answer but in a different way. So up here, I'm not going to multiply anything out. I'm not going to factor anything, but I'm going to delete that, and I'm going to type 7 minus 2x times 3 minus 2x. And then I'm going to click down here, and I'm going to add 6. Now, do you guys notice that that's both the left and the right-hand side of my equation? And maybe I have to type y equals 6. There we go. I have to type y equals 6. Apparently you can't just type 6. So I didn't factor, I just typed in the left side and typed in the right side. And then I'm going to go see where they intersect. What do you notice about 0.919? What do you notice about 4.081? Aren't those the same solutions that we came up with before after doing all of that math? So this is just another way, if you have a graphing calculator as a tool, that you can get to the same answer. You were trying to solve the equation that this 7 minus 2x times 3 minus 2x was equal to 6. So you graph this and you graph this and you see where they're equal, and they're equal right there at 0.919, which is your x value, which we converted into inches, which we found was 11 inches.